Now, yesterday we have done a design up to SRAM error, right? This one. Now, today we will finish this one. Then it is done. Today we will. So here, next is one transistor DRAM cell. One transistor DRAM cell or 1T DRAM cell, 1TD. That means one transistor only. Previous one was 6 transistor SRAM. From here you can understand the SRAM is much more bigger for 1 bit. For 1 bit of information, SRAM is bigger, DRAM is smaller. That means the density of DRAM is more. Density means you can actually accommodate lots of DRAM on single small space. But in terms of SRAM, the space becomes huge because it has 6 cells for only 1 bit. But in this case, you need only 1 bit, 1 register for 1 bit. And the DRAM is a type of RAM that stores each bit of data in a separate capacitor within an integrated circuit. Basic cell larger than SRAM and has to be recharged or refreshed periodically as read operation. Okay, remember the problem and the advantage. Advantage is the basic cell that is smaller than SRAM, but the problem is it has to be refreshed or recharged because there is a capacitor. It has to be refreshed and recharged periodically as operation. Do you know why it has to be recharged or refreshed? Because the capacitor will lose its charges after some time. Because capacitor is not a battery, it cannot hold the current or charges for a longer period of time. So there is an internal resistivity, internal resistance of the capacitor. So it will lose current. No, it will lose charges after some moment. So after some moment, you have to recharge it. Okay, remember. So for write operation, so there is a line called word line. There is a line called data line. This word line can be called as select as well. Select. There is a line called word line, that is select. There is one line that is called data. So here you can see, if I want to write a 1 here, so I will give word line, then or 0. Then I will give the word line 1. Whenever I give the word line 1, the NMOS is on. When it's on, the 1 will go to and store in the capacitor. Because inside the capacitor, let's say there was no charge, so it was 0. So here in the data you have 1. So from 1 to 0 there will be a current flow. This current flow will create some charges inside the capacitor. That means it is 1. So it is a capacitor. Now what do? You switch off the word line. That means the transistor is off. No current can go in, no current can come out. Okay, that means that it is stored. Okay, remember, for the read operation, it is a bit tricky and a bit complicated. What is that? The data pre-charged to VDD by 2. So here you have to give a voltage, not 1, not 0, in between. You have to give a voltage that is in between. That means VDD by 2. If 1 is 5 volt and 0 is 0 volt, so you have to give 2.5 volt, half voltage. You have to give half voltage here. Then you 1 here. Okay, the capacitor shared charges with the data. That means if it was 1 previously, 1 means 5 volt, right? So what will happen from 5 volt to 2.5 volt? What will happen? The current will flow from here to here, right? Because this is 5 volt, this is 2. So obviously there will be a current from where? From here to here, right? So if the direction of the current is this way, that means what? There was 1 here, right? There was 1 here. If this was 0 volt, that means the 0 previously. That means the stored data. Now what will happen? A current will try to from here to here, right? The direction of the current is in this direction. So by measuring measuring the voltage changes, that means the current direction. By measuring the voltage changes or V delta, or whatever you can say, in other way, you can say the direction. By measuring the direction of the current, you can say there was 1 or there was a 0 inside. Got my point? So this is the D, and there will be a controller for controlling the DRAMs and reading and writing a lot of things. Normally, your RAM that you are using inside your phone and inside your computer, the 5 GB RAM, 6 GB RAM, 10 GB RAM, 8 GB RAM, those are all your DRAM. Okay, those are all your DRAM. Understood? Now come to the SRAM and DRAM differences. This is the last from this lecture, and this is a very important lecture for our vivas and our theory as well. Next day we will do something else. We will do logical effort and RC delay. Logical effort and RC delay. Very important class. Next, what is that? Next Thursday, right? Next Thursday, we will have a very important class and very important lab, because we are going to start our lab number 1. Remember, I told you?
Yes, sir.
Okay. Now the SRAM and DRAM. The differences between SRAM and DRAM. The SRAM introduction. Static random access memory, or SRAM, is a type of semiconductor memory that uses bistable latching circuitry. What is that? Bistable latching circuitry to store each bit. The term differentiate. The static differentiate is on the dynamic RAM, which must be periodically refreshed. Right? That means dynamic means you have to do it continuous. That's why it's called dynamic. This means one time. Okay. Once the data is stored, data is stored. That's it. So static and the dynamic random access memory is a type of random memory that stores each bit of data in separate capacitor within an integrated circuit. So remember the two difference. One is bistable latching circuitry. Another one is separate capacitor. Two storage devices. One uses bistable latching circuitry. Another one uses separate capacitor. Okay. Typical application: L2 and L3 cache in CPU. Thursday, I told you about this, right? L2 and L3 cache in CPU. The SRAMs are used. Main memory in a computer, e.g., for example, DDR3, DDR4, even the DDR5 is coming, right? Not for long-term storage. Remember, these are not for long-term storage. Main memory, these are actually your main memory. These are your cache memory, level 2 and level 3 cache memory in the CPU, and main memory in the computer motherboard. Right? Remember, typical sizes. These are the typical sizes: 1 megabyte to 16 megabyte. But nowadays it can be 64 megabyte as well. I have seen some CPU that is 64 MB, 64 megabyte. Now the DRAM cell, they are 1 GB to 2 GB in a smartphone. Nowadays it is not. This is not what this information is not correct, because nowadays we are having a phone that has 18 GB of RAM. 18 GB, right? 18 GB. So you can change it. You can change it if you want. You can change it. This one you can change 1 GB to 16 GB or 18 GB. You can change it because it is already available in the market, right? Right, everyone? You do not have to write 2 GB. Write 16 GB or 18 GB, no problem. Because it is already understood. Now this one, yes, 4 GB to 16 GB in laptops or desktops, right? But this is also changed. Nowadays we have 4 GB RAM, we have 8 GB RAM, we have 16 GB RAM, also have 32 GB RAM, right? That means per stick. Do you understand per stick? Per stick means one stick 32 GB, right? So change the values, because these are actually changing in every 6 months, every 8 months, every 1 year, these data are changing. Now place where they are present. These are present on processor. Remember, processor or between the processor and either they remain in the processor or they remain in the processor and the in between processor and the main memory. But normally they are in the processor. Normally they are in the processor. Present on the motherboard. Okay, better than DRAM because the performance is better than DRAM because it is faster. Not better than SRAM. DRAM is not faster. Okay, expensive. SRAM is more expensive. DRAM is less expensive. Okay. Now our lecture here is finished. These are few examples of FPGA. I suggest you to see all of the videos, right? Have you seen it? Have you watched it?
Yes, sir.
Okay. So I suggest all of you to watch this. Muraz, you can stop the recording now.